Today we are going to start with the factor theorem, but before that, let's once more quickly revise what we did in the remainder theorem. The statement of the remainder theorem was that let p of x be any polynomial of degree greater than or equal to 1, and if alpha is any real number, then if p of x is divided by the linear polynomial x minus alpha, the remainder will be p of alpha. So if dividend is p of x, divisor is x minus alpha, then remainder will be p of alpha. Now what if x minus alpha is a factor of p of x? So when you are dividing two numbers and one is a factor of the other, say for example 15 divided by 3, here obviously the remainder will come as 0. So if divisor is a factor of the dividend, then there will be no remainder. So if x minus alpha happens to be a factor of p of x, p of alpha, that is remainder, will be 0. That is only the factor theorem. So if this is a statement of the factor theorem, if p of x is any polynomial of degree greater than or equal to 1 and alpha is any real number such that p of alpha is equal to 0, p of alpha, that is the remainder, if remainder is equal to 0, then x minus alpha is a factor of p of x. Conversely, if x minus alpha is a factor of p of x, then p of alpha will be 0. So factor theorem and remainder theorem both are related to each other. Let's see problems based on factor theorem. Exercise 2.4, question number 1. Determine which of the following polynomials has a factor x plus 1. The polynomial, first one, polynomial is x cube plus x square plus x plus 1, and g of x is x plus 1. So equate g of x to 0. I get x equal to minus 1. Then substitute this minus 1 in p of x. So p of minus 1 is minus 1 cube plus minus 1 square plus minus 1 plus 1. So which is equal to 0. Therefore, when this polynomial is divided by x plus 1, remainder is coming 0, which means that x plus 1 is a factor of this polynomial. Or we can also say that p of x, that is this polynomial, is a multiple of x plus 1. So both the statements are equivalent. You can also be asked to check whether p of x is a multiple of g of x. So in that case also you are going to find the remainder. If remainder comes equal to 0, then you can conclude that g of x is a factor of p of x. If remainder is not equal to 0, then it is not a factor. Next question is fourth part. P of x is this polynomial, g of x is same, x plus 1. So again we will equate g of x to 0 and find x equal to minus 1. Then you will substitute minus 1 in given polynomial, that is this one. So I get minus 1 cube minus of minus 1 square minus of, now there is a bracket over here, so don't miss that bracket, minus of 2 plus root 2 into minus 1. So here this minus and minus 1, this will become plus. So finally I will get minus 1 plus 2 plus root 2, because this minus and minus have become plus root 2. So the final answer is 2 root 2, which is not equal to 0. So as the value of remainder is not 0, so we can say that this is not a multiple of x plus 1, or x plus 1 is not a factor of p of x. Next question is, use factor theorem to determine whether g of x is a factor of p of x. So again here you will use the same procedure, equate g of x to 0 and this value of x will be substituted in p of x. So basically you are finding the remainder only. If remainder is coming 0, you can conclude that g of x is a factor of p of x. If remainder does not come 0, then it is not a factor. So in first question we are getting remainder as 0. So therefore g of x is a factor of p of x. Second question, polynomial is x cube minus 4x square plus x plus 6 and g of x is x minus 3. So equate x minus 3 to 0, x equal to plus 3 and substitute plus 3 in the given polynomial. So we get 27 minus 36 plus 3 plus 6. Again we are getting 0. So g of x is a factor of p of x. The next type of questions are very important questions. These are application based questions. Find the value of k if x minus 1 is a factor of p of x in each of the following. Now it is already given that x minus 1 is a factor of p of x, which means that you can equate the remainder value to 0. So p of x is this. Here k is a constant which you have to find out. G of x is x minus 1. So equate it to 0. We get x equal to 1. Now you need to substitute this x equal to 1 in the given polynomial. And you can equate it to 0 because it is given x minus 1 is a factor of p of x. So therefore remainder should be 0. So in place of x square plus x plus k, I have substituted 1. 1 square plus 1 plus k. So I get 2 plus k. Now because x minus 1 is a factor of p of x, I will say that p of 1 equal to 0, which is the remainder. So 2 plus k is equal to 0 and k is equal to minus 2 is the required value of k. In the second part, this is the given polynomial. G of x is x minus 1. Now equate g of x to 0, I get x equal to 1. Then substitute this in the given polynomial. I get 2 plus k plus under root 2. Now again it is given g of x is a factor of p of x. So this is the remainder value which must be equal to 0. So k is equal to minus of 2 plus root 2. Or you can also write it as minus 2 minus root 2. The next question, p of x is kx square minus 3x plus k. So g of x is x minus 1 again. Equated to 0, I get x equal to 1. Substitute this in the given polynomial. I get k minus 3 plus k, that is 2k minus 3. Now equate this remainder value to 0. I get k equal to 3 by 2.